Hey everyone, so welcome back to our second day of this week, second lesson at least. We're going to be talking about finding minima and maxima, specifically for quadratic functions, but we'll also talk about how to use it on your graphing calculator and other functions as well. So please make sure, pause the video now, go get your graphing calculator if you don't have it, go get your notes if you aren't ready for those, and we'll get started. So minima and maxima are examples of what we would call extrema. These are called extreme values, so they're like the highest and lowest points that you might see on a function. And there's two main types of extreme values. We have our local extrema, which are the smallest and lowest largest and smallest points in an area. So if you zoom in, they look like a vertex. So if I'm looking at the graph here, find the local minima and maxima. That's just plural. It's a neuter verb for those of you in Latin. And when you zoom in, they look like a vertex. So here would be a local maximum, because we can see here's like the vertex of the parabola. This would be a local maximum. And then down here is the local minimum, because everything around it is bigger in terms of the values of the function. Now, there are also absolute minima and maximum. And so those can be the largest and smallest points of the entire function. So if I'm looking over here, the absolute maximum is this point all the way up here. So we might abbreviate it just abs max. That would be the absolute maximum. Here, the local minimum is also the absolute minimum because it is the smallest value of this whole big function. This is as low as it goes, versus here, this is as high as it goes. This one's only as high as it goes for everything around it. Now, I did say we were going to talk specifically about quadratics. So here we have a quadratic problem. Again, we know it's quadratic because we have this degree 2 here, which means that we're going to be using those skills from previous classes. A soft drink vendor at the beach analyzes her sales records and finds that if she sells X cans of soda in a day, her profit is modeled by this formula. What is her maximum profits, and how many cans must she sell to reach that maximum profit? So in this case, whenever we see a quadratic, we should be thinking about a shape like this of the graph. And our maximum in this case, because we see that it's got a negative leading coefficient, it's going to be down, facing down like this. This is our vertex. Now, if we remember our vertex, that has the x value of negative b over 2a, where y is equal to ax squared plus bx plus c. So in this case, if I'm looking at this quadratic here, I know that a would equal negative 0.001, b is 3, and c would be negative 1800, like so. Now, when I plug that into my formula here, I then get that the x value at the maximum is negative 3 over 2 times negative 0.001. Now, you can do this by hand by moving the decimal point if you like, make yourself happy, but you will also end up with 1500 as your answer. So if x is the cans of soda, that is the number of cans that we would have to sell. So in order to reach the profit, she needs to sell not 15,000. Goodness, that's very different. 1,500 cans of soda. Now the question becomes, what is that maximum profit? Because we want to know the P of x. That means we want to know what P of 1,500 is. And we can plug that into our formula. Negative 0.001 times 1,500 squared plus 3 times 1,500 minus 1,800. and that would give us 450. And we know that this profit is measured in dollars. So $450 is her maximum profit for the day. Now with quadratics, you can do these all by hands pretty easily. This should feel familiar. And again, if it's not, set up a Zoom meeting as soon as possible. What we're going to do new here is looking at some calculator skills. I'm going to show you calculator skills based on TI 83, 84, 89. If you are using an online one, it will work very similarly. If you're using a Casio, most of these things will be similar. I would recommend that you Google if you want exact, very specific instructions, or you can set up a Zoom meeting and I'm happy to walk you through it. So the first thing you want to do is, okay, we want to find the extrema of this function here. So it's not quadratic, so we can't use the vertex formula because this has a degree of 3. And if you graph it, it looks like this. And the way that we can graph that is the first thing you want to do is you want to go to your Zoom standard, and that just makes sure that your window is what I like to call 10 by 10. So it means that it goes from -10 over here to 10 this way, and -10 to 10 on the X. And it's just a nice place to start looking at most graphs. And then what you want to do is you want to hit the Y button and you type in the function. Now for some of you, the exponent key is just going to leave it like this. That's fine. We'll type in x to the power of 3 minus 8x plus 1, which is this function here. Then what you want to do, just to make sure, if you are nervous, you're like, I don't know if I did this right, click Graph, which is a separate button, and it will take you to something that should look exactly like this. If it doesn't look quite like this, see if you maybe mistyped anything here. Make sure that you're using the standard 10 by 10 window, and if those don't work, please, again, as always, set up a Zoom call. Now, we want to find the extreme values. We want to know what's happening right here and right here at our local maximum and minimum. So the way that we're going to do that is your calculator lets you find a lot of different values about the graph. And the way you do that is you go to the trace button, and you actually don't click the trace button. You click its second function, which is calculate. So you want to click second and then the trace button to get the secondary function of the button. And it will get you options of all the different things that it can help you calculate. Value, 0 or roots, which we'll talk about in question 4, minimum and maximum, and intersect. There'll be more. These are your main ones. We're going to focus on minimum and maximum for this lesson. So let's find the maximum first. So what you want to do is click on the one that you want. So in this case, we want to do maximum. And then what you'll see is you'll start seeing a little cursor on your graph. It'll kind of look like this. And you want to use the arrow keys, right, that look like this. And you want to move that cursor along until it is your left estimate. And so it'll be blinking here, and then click enter. And what you're going to see there is then on your screen, either at the top or bottom, you will see a little arrow. And what this means is that your calculator's not that smart, but it will now say, okay, I'm looking for the smallest number in this area. Oh wait, did I say maximum? Oh, now I'm calculating minimum. Okay, so let's go back. Let's do minimum since I'm already here. Sorry about that, everyone. So minimum, clicking there. And then once you click enter, you want to keep moving it with those arrow keys till you're on the other side and click enter again for your right bound. And this just tells you, the calculator, what to look for. Because if the calculator starts looking at every single option, it's going to explode. It's not that smart. So you got to give it a little narrow window to look at. And then you click enter one more time and it will plot a point exactly there on your graph. And at the bottom, it will tell you your X values, which in this case are 1.633. And then it will tell you your Y value, which is -7.7. and that's the ordered pair right here, 1.6, negative 7.7. That's your local minimum. You'd go through the same process, but click maximum first, like you did at the beginning, and I am sorry I misled you. It was a fun prank for us all. To find the maximum, you'll find the left bound, the right one, click enter, and it will give you this maximum value here, which in this case is the point negative 1.6 and 9.7. So that's how you find your maximums and minimums. Now your last thing that you're going to want to do is find the root of a function. Now roots are where the graph crosses the x-axis. So in case of this graph here, x cubed minus 8x plus 1, the roots are these 3 points here. And you're going to go through the same steps as before. If you haven't already, graph it, check to make sure that your graph makes sense, and then go to second trace. And then instead of picking min or max, you're going to pick the 0 or the root. Now you're going to have to do this 3 times because there's 3 roots here. But it'll start you off again, beep, beep, beep. Move it using the arrows until you have, again, a bound here and then a bound on the right. So you'll end up with, maybe they're on the bottom on your calculator. The same applies. It's just saying, look for a root in this space. And then again, you'll click enter so that it can actually do the work. And you end up with the hopeful y value of 0, because that's what makes it a root. And then it will tell you your x value, which in this case is 0.125. Now, because there's 3 roots, you will repeat that for all of them, and you should eventually end up with the other 2 roots as 2.764 and negative 2.889. Let me know if you have any questions on how to use your calculator or how to find any of your minimum, maximum, or roots for this lesson. I'll talk